Let's take a look at this problem in the 3.5 homework. We're looking at derivatives of trigonometric functions. The function given in this problem was y is equal to 23 sine of t minus 1, and it's the sine of t minus 1 all inside of a group multiplying 23. So whenever I was thinking about how we would graph that function, I wanted to remind myself of the base graph of a sine function right here. We know in general the sine of 0 is 0, and then it's going to go up to the value pi over 2, 1, back down to pi 0, down to 3 pi over 2, negative 1, and then back up to 2 pi 0. And then it continues on like this periodically. I went ahead and did half of a period over on the left-hand side. We don't need it for this problem, though. Now, when I thought of the impact of this problem, this has the sine of t minus 1. That's going to vertically shift my sine function down 1 unit. So the sine of t minus 1 would have a maximum at pi over 2, 0. It would have a minimum at 3 pi over 2, negative 2. Now, after I shift it down 1, that group is then multiplied by a factor of 23. Well, that's just going to multiply the amplitude. So whenever I'm thinking about that, I can say, well, my sine function would have had a value of 0 at pi equals 2. Well, when you multiply that by 23, you still have a value of 0 at pi over 2. Now, the value that would have been at the origin is shifted down 1. Then you multiply that by 23. That's why I said I knew I start at the ordered pair 0, negative 23. I'd go up to pi over 2, 0. I'd have also the point pi, negative 23. And this point 3 pi over 2, it got shifted down 1 unit to negative 2. That got multiplied by 23. That's where I'm getting the negative 46 down here for the 3 pi over 2. Once I get that, I just continue the pattern. I'd have 2 pi over 3, negative 23. Back up, my next intercept would be at 5 pi over 2, 0. And of course, it continues down. You could say you'd have the value 3 pi, comma, negative 23, 7 pi over 2, comma, negative 46, and so forth. Now, this was enough for me to pick out the graph over here. Notice it couldn't be A because A starts off going down. It could have been B, and it ended up being B. It can't be C because it's going down. And it can't be D because it has positive values. B is the only one it could equal. Now, looking even closer at B, you can know it's that because 3 pi over 2 it's approximately like 4.71. So just short of just short of positive 5, this function is going to take on its minimum value. And notice that's exactly what's happening here. Just to the left of 5, right at 3 pi over 2, about 4.71, this function takes on its low value. I knew it had to be B. Now for part B, it's asking just for the velocity function. Well, velocity is the derivative of the position function. What I wanted to go ahead and do is I distributed my 23 through my position function. And I said, well, the position function is 23 sine t minus 23. I take the derivative of that. Well, the derivative of 23 sine t is 23 cosine t. And of course, the derivative of any constant is 0, so that dropped out. That made it very easy to graph. So, of course, that's my answer for B. That's the 23 cosine t. Then it asked me to graph the velocity function. Well, the velocity function is just a magnitude of 23 times the cosine function. You'd say normally the cosine function would start at the ordered pair 0, 1. Then it'd go to pi over 2, 0. Then down to pi, negative 1. Then back up to 3 pi over 2, 0, and then it would finish the period at 2 pi, 1. Well, this is that exact same shape, except it's stretched by a factor of 23. So your high values, like at 0, are 0, 23. Your low values, such as at pi, are at negative 23. Now, whenever I used that graph to find the correct answer for part C here. Again, I knew it couldn't be B because it starts off increasing. Can't be C because it starts off increasing. The cosine function has to start off decreasing. Well, that left us with the choice of A or D. And then I know it had to be A because if you look at D, all of the y values are negative. That's not the case with this. We start off positive at 0.23, and then at pi over 2 radians, approximately 1.57. So notice about halfway between 1 and 2, we had our first x-intercept. So had to be A there. Now, part D over here, it asks at what times and positions is the velocity 0? Not bad at all. You just say, well, all I have to do, the velocity equation is what I had right here. It's equal to 0 when I set my velocity equation equal to 0. And then that's going to be 0 whenever the cosine function is 0. And you say, well, the cosine function is 0 anytime you're going vertically on the unit circle. That's at an angle of pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. I'd rather you just say, oh, it's at pi over 2 plus n times pi. That's going to keep on adding pi radians to that, and it'll keep on taking you to each successive value on your unit circle. That's going to be either vertically up or vertically down, at which the cosine is 0. Now, of course, their answer here didn't use the n pi, but you could easily get to that from this. You could say, oh, okay, that's pi over 2 plus pi is 3 pi over 2 plus pi is 5 pi over 2. If you kept on adding pi, you'd just say, well, 7 pi over 2, 9 pi over 2, 11 pi over 2, so forth. This gives us an equation for all of them. This is the only answer here that made any sense. At what times and positions is the velocity a maximum? Well, the velocity is a maximum whenever your first derivative is at a maximum. Your first derivative is at a maximum here at the beginning. You can see at 0.23, the maximum velocity of this function is going to be 23. So you could say, well, okay, it's at its maximum there, and it's not going to attain that maximum again until the cycle completes at another 2 pi radians. And then you could say, well, that maximum would occur again when the cycle completes at yet another 2 pi radians. So unlike where the derivative is equal to 0, and that's going to occur every pi units, this is only occurring every 2 pi units because it has to complete its entire cycle. So I'd say, well, okay, that's going to be at, if I look at this, B, because it's giving me the value 0, 2 pi, 4 pi, so forth. And we know at each of those, the value is going to be 23 in those. They shouldn't have put negative 20. They should have put 23. Bad, my lab. Should be 0, 23, 2 pi, 23, 4 pi, 23, and so forth. But that's the only reasonable answer there. But those negatives should not be on the y values. F says the acceleration of the oscillator is the derivative of velocity. And so we can say, well, okay, we knew our velocity function was 23 cosine t. The derivative of that is going to be negative 23 sine of t, since the derivative of cosine is negative sine. So then I can say, well, okay, I get my acceleration, negative 23 sine t. That's the answer for F. And then the answer for the final one is just graphing that acceleration function. So you say, okay, it's the graph of the negative sine of t magnified by a y value of 23. So I can say, well, okay, my original sine function was up here. The negative sine would end up looking like that. And then we're just going to multiply that by 23. So I would need to say, I need to find a value of pi over 2 negative 23, 3 pi over 2 positive 23. And when I'm looking at that here, it cannot be, let's see, the first one, because we know if we're just saying negative 23 sine t, we're starting at the origin. So A doesn't start at the origin, can't be that. B does start at the origin, but notice it goes upwards. The negative sign function is going to start off going downwards, so it can't be B. A doesn't start at the origin, can't be that. Has to be D, because you say, okay, D, it's going to start off like that, and it's going to reach a value of negative 23 at pi over 2. Then it's going to go up like this. It's going to reach a value of 23 at positive 3 pi over 2, or approximately 4.7, which notice is right before the value of 5 that it takes its maximum value there. And that would be the end of this question. Hopefully this helps you out with it.